Second is data transformation. Third is, second is data integration. Third is data transformation. Fourth is data reduction. These are four techniques you need to use for pre-processing. So if you apply these four kinds of transformations, your data is ready for pre-processing. So then what we discussed is, before you really go for pre-processing and all, you should know the behavior of the data. So to know how the behavior of the data and how the things are there, and for some interpretation purpose, for the visualization purpose, you will go about the data we were discussing. So for that we were looking into some statistical measures. So yesterday we had a broader view of what all four categories are. So I have given just a very brief introduction about each category. Then I started the statistical application system. So today what we will be doing is the remaining part of the visualization aspects I will be discussing, okay, which are important things, and then I will be starting the different 4 steps of your clean. So today I will cover the statistical tests, remaining things, visualization things, and then I will consider the data cleaning part, how it will be done. Okay. So the quartiles, outliers and box plots we said. Then what is a quartile? See, in some of the examinations nowadays, you are habituated for the percentile ranking, right? So this is in a similar fashion. Okay. What is the percentile concept? Suppose somebody gets, you appear for an exam. The highest mark could be 60 only out of 100. But at the lowest mark is 20, let us suppose. So here what happens is your 60 is considered as the cent percent. That means the person who gets 60 means all the remaining people are below him. So he had 100%. Suppose somebody's rank is 3 in a set of 100, his percentile is 97. There are 100 members, your rank is 3. So that means you have 97 people below, right? So that is how you consider the percentile. So here also we consider the percentile concept. That means your 25% is called quartile 1. So that means 25% of the total data set points, where they lie, you draw a line there, say that that is the first quartile. So that means 1/4 of the total elements are there in that. So that means you call this as quartile 1 or 25 percentile. So that means 25% of the records are below this. It is a meaning, equal to, less than or equal to that. That is the meaning of the quartile. Similarly, what is the median? It is a central point. That means you have 50% of the things less than or equal to, right? So that is the second quartile. So third quartile is 75% elements where they come to. There you will draw a line. So below that 75% of the elements will be there at the third quartile. Is it clear to you? Yesterday your quartile and I said percentage. You had a confusion. I said the percentage of total elements. Is it clear to you now? So this is what we consider. So we consider Q1, Q2, Q3. They are the 3 quartiles you consider, and the minimum of the data set, maximum of the data set. You consider minimum of the data set, maximum of the data set, and these three quartiles we consider. So this is called a 5-number summary. So minimum Q1 is first quartile, Q2 means it is median, right? Q3 is the third quartile, and then the max value in the set. So you have a set of 100 elements. So the value where the 25th element comes into, there you draw those 25 elements, that is the first quartile, and 25th element to the 50th element, that is the second quartile. The numbers, it's not the width, please remember. If more number of elements are there in second quartile, first quartile, the width might be less. There are 100 elements, but the first quartile might range from 0 to 10, and second quartile might range from 10 to 15 only. So within 5 range, another 25 things might have fallen. I told you the marks range, the marks obtained and the number of students. So first 25% of the students in the class, what is that mark? It will be marked there. Is it clear to you? Such way. Okay. Then what is your box plot? How does it look like? The box plot is end of the boxes are the quartiles. So the box will be shown with quartiles only, and min and max, the median will be mentioned. And you add whiskers. Whiskers means the dotted lines, and plot outliers individually. Next slide చూపించండి. ఇందులో బొమ్మ ఇవ్వకపోతే కనుక see here the lower quartile. So the lower quartile, there is lower extreme, that is the minimum number. It is something like 16 or 17. See in that case, point. See the lower extreme, lower extreme, lower extreme. Here to the left, lower extremity. If you look at the bottom, come down, it is pointing to something like 17 or something in the right. It is approximately to 17 or 18 it comes. That is the lower extreme. Then the lower quartile, see there. This is the Q1. So this is the Q1 starting, and median is Q2 starting, and upper quartile is there. That is the Q3 starting of Q3. So that means the lower quartile beginning is there. Okay, so minimum to that. So 25% of the things are there. Okay. Then quartile 1 to quartile 2, 25 to 50% in between values are there from lower quartile to median in that box ring. Below this lower quartile, you have the first 0 to 25% values. And then after the third quartile, so upper quartile is beginning of the third quartile. That is, okay? That is the beginning of the third quartile. Then from there to the upper extreme, remaining 25% of the elements are there. Okay? So that is how the box plot is drawn. Now the issue is here, you will have some outliers. And one more concept is there called IQR, interquartile range. The IQR is considered as 1.5 times Q3 minus Q1. So your beginning of Q3 that is upper quartile, that yes, minus that lower quartile is there, no? That is beginning of Q1. So this straight line of the box length, that is the interquartile range, IQR. Okay. Now you consider any point as an outlier. Okay. If it falls beyond the range of 1.5 IQR from the third quartile, beginning of the third quartile, not from the end. That means the third quartile beginning is this point, upper quartile. See, from here to the top, to the other side, you consider 1.5 times of interquartile IQR distance, and any point falls beyond that, that is considered as an outlier. Similarly, on this side also, from lower quartile, you consider 1.5 IQR, and any points beyond that are also outliers. Though they represent very poor items, the ones represent the very special top items. Okay, so that is how you identify the outliers in a box plot. Okay, so this is one visualization technique. So what is that you get out of this box plot? Because you draw certain box plots for different kinds of data sets. So there you will understand how the spread is. Because your length, see, between 17 to the median is at approximately 68 or something. The median is. So 17 to 67 or something, let us say. In that range, 50% of the elements are there. And remaining 50% of the elements are covered from 67 to 100. Suppose E case, you consider this case. So what is meant by that? Median means that's the mid element. Okay. So that means here the lower extreme is 17, and let us suppose it is 67, it is nearing 70, right? You consider this. From the median, right? It's something like 67 or 68. Let us say it is 67. So 67 minus 17, that is the lower half, right? Median means the 50%. So to the left is lower 50%. To the right is the upper 50%. Agree? So your upper extreme is finished at 100, right? So this says that 50 lower and 50% elements are ranging from 17 to 67. Got it? And the remaining 50% are there from 67 to 100. The 33, within 33% of the margin, within a 33 width, half of the elements are there. So suppose it is income, let us say. So half the people are, 50% of the people are high income persons. Let us suppose any income beyond $60,000. Let us suppose this is the salary wage distribution. Okay. So 50% of the people are lower end people are from $17,000 to $67,000 range. And another 50% of the people are there from $67,000 to $100,000 range. Let us suppose that's our bracket. So 50% are in the upper bracket. Okay. The lower bracket is that. Again, you suppose consider the first quartile is the minimum starting of some mediocre income range. Suppose you have your income ranges, low, medium and high. Let us consider. So if you consider a low income range that starts from 17 to 50 is low income ranges. So up to 50 what percentile comes you can notice. So those many are in the lower income group, then the remaining are in middle income group. So how much percentage of the people are there in different income ranges can be obtained from here, right? And if you have two box plots of two different variables, you can compare also. Let us suppose this is the income in one state, one developed state. Okay, suppose if you consider in US, the California is the richest state. Then New York is another rich state. New Jersey is very rich state. If you consider some of the southern remote states, wherein much like Kentucky or something, they are not very rich states. Okay. So suppose that is the income range, like suppose for the people in that place. Okay, otherwise you can consider our Indian scenario itself. Okay, you consider the salary ranges of Hyderabad and Bombay, let us. So you get two box plots. Then you can say in Bombay how many low income people are there, what is their range. Yes, Hyderabad against. You can compare both the box plots where the spread is there. In Bombay, how many very rich people are there? Hyderabad, how are they? Then what you can do is for what reason they are in a very high bracket. As in Bombay, you have these places wherein this much salary is there. So such kind of things are not there. So suppose tomorrow Microsoft starts their center there. Google starts their center there. Again in Hyderabad, very high income people will come. Then similarly, you can compare the prices of both the cities and all using a kind of box. Of course, than that, next one is the quantile. That gives a still better idea for a visualization. So he has shown different. The median is marked by line width box. Data is represented with a box. Ends of the box are first and third quartile. I told you, first and third quartiles are the end points of the things. And the height of the box is IQ. Interquartile range is the height of the box. Then median is marked. Whiskers, two lines outside the box extend to minimum and maximum points. And outliers are points beyond a specific outlier threshold plotted individually. Actually, he has not shown, but actually suppose something goes beyond those two things above that max line will be shown. Okay, the outliers will be shown like. So next, this is a visualization of data dispersion in a 3D box plot. 3D box plot. He has shown revenue, cost and profit. So 3D plot. Next. Actually, the properties of a normal distribution curve, though is not included at this point, I would just like to tell you. See, I didn't talk to you about the standard deviation yet, still, but you know the standard deviation. What is meant by standard deviation? I spoke to you about mean, median. Oh, right, standard deviation calculations are there in the back. Again, I think standard deviation, yeah. Clear, ముందుకు Next, 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 next. Variance. Next. Right. Median. Next. Next. This one. See, the variance and standard deviation, these are the measures for the spread. See, median means the central point. Arithmetic means that it is the average mean point of the values. Okay. Now, what we consider something called variance. That means what is the distance, rather what is the spread of the total data from the central point is a tendency. That's called the variance. How much they vary from the central point. So here, for that what they do is first they calculate the arithmetic mean. They calculate the arithmetic mean. So from arithmetic mean, how much deviation is there for each and every point they consider. So that is considered as one measure. Okay. So here if you consider S square, variance. It is considered as 1 by n minus 1 into sigma of xi minus x bar whole square, I running from 1 to n. That means xi minus, and that means x1 minus average, x2 minus average, x3 minus average. You will square all the values. You will square the deviations. So you get a positive value. That's square. Whether it's negative or whatever. That means irrespective of direction, you get the value around. So that is sigma 1 to n from xi minus x bar whole square 1 by n minus 1. So it is 1 by n minus 1 I running, it is spread across. So your sigma square is considered as 1 by n into x minus mu whole square, xi minus mu. Mu is considered as your mean. So see, this is xi minus x bar square. This is expanded like this, xi square minus 1 by n into xi square. So it is considered as xi minus mu whole square 1 by n into. So that is equal to 1 by n into sigma xi square minus mu square. So that is the final outcome of it. Okay. So that is called the variance. So variance means how much spread is there, how much variation is there from the central point. That is the measure for the variance or the distance measure. And standard deviation is the square root of variance. That is called the standard deviation. So this is a measure for the central tendency. Now in the slide. So here mu means the arithmetic mean. Okay. Sigma is the standard deviation. So here I said you have a normal curve like this, is ranging from -3 to +3. So the area of the curve is the total population, is the area of the curve for any distribution. See, if you has considered the range, so your central, the peak is the mean, median and mode. All the three are one and the same for a normal distribution because it has got a equal spread on either side. Then what he has considered is, he considered mu, that is the mean point, right? So mean point will be this, where he is pointing out. So from that, on either side, you allow minus sigma on this side, plus sigma on that side. So if you consider those 2 points and count the area, it is covering around 68% of the total population. So that means here, what is the interpretation of this? In any normal distribution curve, generally, majority of the people, they are at the average level. They are at the average level. That is the implication. So just with the one standard deviation difference from this mean, as I said, 68%. If you consider 2 sigma difference, it is almost 96% coverage. 3 sigma is 99.7. It is like this with the normal distribution. Okay. Next slide, please. So, graphic displays of basic statistical descriptions. One is the box plot, I said. Another is histogram, quantile plot, and quantile-quantile plot, and scattered plot. These are the 3 kinds of, these are the 5 kinds of statistical distribution plots. So box plot we have considered right now. Now we will go to histogram. Histogram is a very easy and comfortable thing. But about quantile plot and QQ plot, you have to focus a little. Some statistical. Here what happens is, every point that will be replaced by its percentile in your quantile plot. That's the thing. Okay. But you have to have a little understanding. So, histogram, you know pretty well. You will have equal frequencies and the total number among the equal frequency you picturize as a bar. That's a very simple thing. Anyhow, you will see that also. Now coming to the quantile plot, what you will do is, you have to sort all the elements. You have to sort all the elements in ascending order to draw a quantile plot. Now, what you will do is, you will find out the percentiles. So what happens is, each value is xi is paired with fi, indicating approximately 100 into fi% of data are less than or equal to xi. That means what he does is, suppose I is 1. You have 10 points, let us suppose. I minus 0.5 by n is considered as fi. Okay. I minus n by I minus 0.5 by n. I'll show you with an example. Okay. And quantile-quantile scattered plot. Next slide, please. I'll explain you about the quantile plot. Histogram. Okay. Next. Quantile plot histograms. 2 histograms shown. Represent the same values for min q, but they are rather different data. Come back. So histogram is the graphic display of tabulated frequencies shown as bars. It shows what proportion of cases fall into each of several categories. So your histogram is a graph display of tabulated frequencies shown as bars. So that means in which range, what is the frequency of the elements? Those frequencies will be considered and the range is equal range is considered. So within that range, what is the frequency? So 10 to 20, if you consider this range, how many items are there falling in that? Again from 21 to 40, how many elements are falling in the range? So like this, you will have the frequencies. It show what proportion of cases fall into each of several categories. See, you have 1000, 3000, 5000, they are marked here. But see, in the 1000 itself, you have different categories. So the frequencies, the width is the same, please remember that. Okay. So within that width, how many number are there? The first one, there are around 3-4 numbers. For the second one, only 5 numbers, let us suppose. If you consider the third one, you have around 14 or something, right? And the other ones are little less. The corresponding ones here will be something like the 1000 is the maximum one. So it will be like 200, 300, 400, 500. These are the ranges. So between 100 and 200, 200 to 300, how many elements will be there? So that is a kind of histogram. So difference from a bar chart into several categories. This histogram differs from a bar chart in that it is the area of the bar that denotes the value, not the height as in bar chart. Because in your box plots and other things, the height is the measure for your values. Here the area covers the number. Okay. A circular distinction, a crucial distinction when the categories are not of uniform width. If the categories are not of uniform width, then the area will be a better thing. So the categories are usually specified as non-overlapping intervals of some variable. The categories bars must adjust it. Next slide, please. I'll show you in the other one, the other slide I will show you the things. The two histograms are shown in the left may have the same box plot representation. These are two histograms actually. In this histogram, within this range, it is similar for both the things. In the second histogram, in the second range, the number is more. The width is number of things are more. Here it is less. Now what he says is, these two are representing two histograms. Okay. So they are representing different information. Okay. But whereas if you consider the box plot for these two, box plot for these two is the same, but histogram is different. Right? So see, why box plot is the same? Your minimum is same here. Your quartile Q1 is the same for median, Q3 and max are same for both the distributions. Okay. Now let us find out one interesting point. Why the box plots are same but whereas these things are different means, in the box plot, what is that you are plotting? This is one kind of view. You are saying the percentile, how many percent, that is a univariate one, please remember. How many percentile of the elements are in one specific range with reference to one variable. But here the thing is, you have the range here and the y-axis is the frequency of those items. So this is different basically. I think I show you another example wherein you will have a better perspective. So here the freaks are differing. So here what does this imply? In this range the sales is more, there it is less. But he has not shown the values. Now you go to the second PPT I have shown. There we will go to the slides. You will have a better understanding. Because he has shown with some data. Next. Next, please. See here, you will have a better understanding with this example. Here what he shows is, see, unit price and count of the items sold. So this is one supermarket example. In the supermarket, you have $40 price items. How many items were sold? 275 items were sold in. And $40 price, 300 items were sold. Similarly, some $48, 250 items. Like this, $74, 360 items, $75, 515 items, $78, 540 items. Similarly, etc. $115, 320 items. $117, you have 270 items. $120, 350. So now your histogram means you are drawing the histogram based on the width represents your unit price ranges. So you want to have between $40 and $59, that range. How many are there is the representation. And 60 to 79, that's the range. How many items are there? 80 to 99, 100 to 119, 120 to 139. So these are different ranges of things. Now, how do you get between 40 and 59? See, 40, 275, 43, 300, 47, 250. You sum up all those figures up to 59. The price is 40, 43, 47. After that, you have different tuples, right? The amount and its frequency. So, ranging from 40 up to 59, you count the items. So, now you take this area. So, that is approximately count of the items sold is 2,800 or something, just below 3,000, right? So, that is. So, here, what does it imply? Around 3,000 items are sold within the price range of 40 to 59. And 60 to 79, 4,000 plus items are sold. Between 80 and 99, around 5,000 items were sold. This is your histogram. So what does this imply basically? What kind of inferences you can draw from this? The kind of inferences you can draw from this are, yes, exactly. Within what range, how many items are being sold? Okay. So that means here it implies the kind of purchase potential as well as the need of the people. So probably most of the items that are needed at a specific place are ranging in the price range of $80 to $99. So those items were sold the most. And one more thing is, this depends on the income range of the people in that area. And then what they will do is, okay, between $80 and $99 price slim range, what are the items that are coming? So from this, they will find out the purchase patterns. So the people in this area are interested in cosmetics of this price, food items of this price, tinned items of this price, luxury items of this price, electronic goods of this price. These are the items that are being sold better in this. So accordingly, they will manipulate the stock. They will optimize their stock position. So our histogram gives that kind of analysis. Whereas how does your box plot? In the box plot, you don't have two variables. You have only one variable. So across this one variable, how the spread of population is there. So that is one perspective, and this is a different perspective. Right? That's the reason why he has shown two box plots they are showing only one perspective with reference to some income range, or that could be price range also. With reference to just one thing, the plots, the spread is uniform, but still the items price range, their purchase potential is obtained here. Got my point? So these are two different perspectives here. Okay. So next slide, please. So what is this quantile plot? For this quantile plot, to have a better understanding, I'll just work out a very simple example on the board. On the board, so that you will have some better perspective about it. See here also, please remember the values. If you consider the unit price in the previous table, $40 is the minimum price, right? $120 is the maximum price. So remember, your F value versus unit price is ranging in that. So I'll show you one simple example. How do we calculate this and draw this plot? I think you are not familiar with these things, right? Before. Box plot, cube plot, right? But you know about mean, median, variance and those. But what is their physical interpretation? I think you are understanding now. Suppose I consider 10 elements for the ease of calculation. Okay. Are they visible and the board visible? My dear students from different classes, is the board visible? Huh? Oh, board is visible. Now, I said your box plot, we are considering Fi as I minus 0.5 by n. I minus 0.5 by n, we are considering as F. So, first of all, you have to keep the numbers in ascending order. For our convenience, I have put them in ascending order straight away. You have 10 numbers. So your n is equal to 10. Your n is equal to 10. So Fi is I minus 0.5 by n. This is it. So now, what is the first one? This is 1, right? 1 minus 0.5 by 10. So your F1 will be 0.0. What is your F2? I is 2. 2 minus. So 0.15. Similarly, the next is 0.25. Your F10 will be 10 minus 0.9. Right? So these are different percentiles of these things we will be considering. So now if you plot this, it is the graph you consider. These are the points. Now you have here okay. Let us suppose these are the. Now yours says F1 is 0.05. 0.0570 is the first item. So 0.05 comes somewhere here. This is the first point. Next is 0.1572. 0.15 comes somewhere here in between and 72. So this comes. Similarly, 0.25 and 74. So this is somewhere. And then 0.35 with 75. Then 0.45 with 78. So 0.55. Hello. Yes. 0.55. Then 0.65 with some 79 or something. 80. Then 81. This with something. This is somewhere here. 0.95 is. So that is how your graph is. So if you draw this, something like a line. This goes that way. Now you see the plot in this. You go to the so here what is meant by this? F is 0.05 means this is percentile. Almost the similar way the numbers are. Of course, I have shown you only line and some spread. There it is, the points are line. So now I hope how to calculate this, because if I show you with a simple example, you can calculate better. If you have 9 numbers, it will be divided by 9, 8 divided by 8. I minus 0.5 by n. In fact, of course, I by n represents the percentage of that literally, but 0.5 is some adjustment I feel. Okay, even I have no clarity about it. Actually, I thought of, I'll explore sometime. But that 0.5 difference for some reason I think to not to start with 0, they want to have some minimum gap or something, could be the reason. Anyway, so with that reason they made minus 0.5. So it is defined like that, but there is, I don't know the very exact reason, but I'll try to explore that. So it is taken in that fashion. And see, here also 40, this is 0, 0, is a bit away from the 0, right? Like I have shown you the 0.05. Maybe I think they don't want to start it exactly from 0, because it will not touch 0, right? The minimum quantile thing they want to have, because the first one, they don't want to say 0 quantile, they don't want to have. So from the first, it's starting from 0.05. So that means here 0.05 means what is the meaning? 5% of the elements are below that. Yes, I could say easily now. I didn't think of it. Say please, you say that 0% means nothing is there, right? So 0.05 means, of course, by 10 is that 0.05. So that means 5% of the things are below that point. Let us suppose see this part is 0, is 0, 0, 0. This is 0.25. So it is coming like 0.001 or something, let us say. So 1% of the things are below that. In fact, your quantiles are nothing but the percentiles. Your 50th is the median. See, F value 0.5 is there. That is median. 0.25 is your first quartile. 0.75 is third quartile. Got my point? So that is how the things are there. And the further spread and other things. So here, what is this giving your quantile plot? So 1% of the elements at 40%, $40 price. Suppose you come to the next element. It is maybe some 3% or something. So 3% of the elements are below some $43. Getting the logic here? The interpretation of it? So why minus 0.5 is yes. That is the reason. Because 0 percentile doesn't make any sense. So let us start from some minimum value. So with that, that minus 0.5 is there. Is it clear? Then next is something like 0.3 or so, something like some 30% are below this, 40% are below this. Sorry, this is 0.25, no? Sorry, 13%, 14%, 16% are within that range. So this shows how many percent of the elements or at what price range is given in the quantile. Got the logic? So your box plot, what is it showing? It is just showing only the range of it, quartile things only. But this is showing a continuous step of those things, how the thing is ranging. In your box plot also what is there? Your 40 is the minimum and 120 is the maximum kind of thing, and sorry, that is the price one. These are the FPs. Okay. So this is the difference between that box plot and this. This gives you in fact a better perspective. Within how much percentage, how many things are there. Okay. What is your histogram showing? Histogram is showing frequencies and prices. That means how many, here the frequencies are not mentioned. This is univariate, please remember. Histogram is bivariate. What is that saying? It is saying that in this price range, these many items are sold. In this price range, these many items are sold. That is giving another perspective of the study. So for you to have different perspectives of study and to have a full understanding of the business process or the business trends, you require both. Okay. Here it shows how many items are there within this range is studied from there. There within price range, how many people purchase the stuff is there in histogram. Is it clear, my dear friend? Then what is your QQ plot? The next. Next. See here you have one box plot, one quantile plot of one store. Let us say. You have a quantile plot of another stores. Let us say. Now you want to compare both the branch prices. That means previous one is your quantiles of one particular branch for pricing. Let us suppose you had two such plots. Now you want to study the variation of these two store prices. So for that what you do is you will have the quantile points of first stores and you will have the quantile plot of second stores. And you will plot those points. See, branch 2 unit prices in dollars, branch 1 unit prices in dollars. Okay. So your first quantile of one branch where it is showing. Another thing is there for this branch. So the quantiles are placed there. See, this is the first quartile 60, second quartile and third quartile, the dark things. So this shows a relative comparison of these two branches, quartile sales. Okay. So at some place you will see initially the branch 1 price against branch 2 price. If you consider this point, see, what does it indicate? Branch 1 at this quantile, the price is something like $42 or something. For branch 1, the price is at about $45 or something. So in that quantile point, so first quantile point, the price in the first branch is around 42, whereas this 45. So for that price range, so for those items of that quantile, branch 1 is offering a lower price. And you have a confusion here, how it is plotted? Right. You have the quantile plot for one branch. I have shown you previously. You have the quantile plot for second branch also. The quantile points should be the same, please remember. And if indaka I have shown you some 10 points, right? 0.05, 0.15, 0.25, like I have shown points, right? So that is for one branch, let us say. For another branch also, you take, suppose you consider more supermarket. You have one branch here at JNTU, one branch at Two-Town Police Station, another branch at main road, let us suppose. So now what you will do is, you will have the quantile plot for prices of JNTU branch. You will take only 10 quantiles. Here, please remember, you should have identical quantiles in both the graphs. That is the base condition. Now what you will do is, what is this graph now? For the first quantile point, suppose 43 is the branch 1 price, 45 is the branch 2 price. So 43 on x-axis and 45 on y-axis is the element, second element is. So the second element represents 0.15, let us suppose. So for the 15% of quantile point, branch 1 is selling the price, items at $42 price. Whereas branch 1 is selling at about $45 price. Got my point? I hope it is clear to you now. Now you may say, sir, is it necessary that all the quantiles need not be identical? Because in one plot you may have 100, second plot you might be having 120. Alagadamma, ikkada manamu we have considered some 10 points, 10 points in this, 10 values in this. And the thing is, see, this is the price range, right? Because you have considered the stores. In a stores, the prices are, minimum price of the items is $40. Maximum price of the item is $120. Agree? Now the thing is, how many members purchased in the stores you have come across? Okay. So, I have shown you previously some elements, 72, 78. These are some numbers, right? So, your price here is starting from 40 to 120, right? So, for those numbers, you will be drawing the quantile plot. So, how you are considering is, suppose you want to make it 10 ranges. And then quartile deviation, and what is that you have understood? 25% of the total sale elements. This is with reference to the sale elements. These are the prices, that is the number of sale items. So previously that 72, 80, 81 and I have shown 72 elements are there. 80 is the population. So they are the numbers. Okay. Exactly. So if there are 10 numbers, that is the n is the population length, right? Here also the population length you consider. If it is 100, let us suppose your 1 by n is 0.01. So suppose you have 100 elements, let us suppose. You have to sort the 100 elements. That is 100 purchase patterns. And need not be different items. 100 members purchased. So the first member at some $72. So first member at 40, then 50. These are the purchase patterns. Okay. I think I will make a still clear example for you in the next class. Okay. Anyhow. Okay. So what you will be doing is how many percent of elements are purchased before. So those points you are considering. Come to the previous plot. Come to the previous. See here, what is this? Your $40 to 120 only, they are the prices, right? Prices purchased. Here, this is F value, means frequency value is said. Actually, the counts are, so how many people purchase this? Suppose there are 100 people purchase those items. So you are mapping into the range of 0 to 100, all those things. If 10,000 purchase patterns are there, that means the first person, he purchased something for $43. Another person something. The dollar price I am not considering here. First of all, how many purchased? 100 members are there, 1000 members are there. But I am ranging that from 0 to 1. 0 to 1. So here, like your median. So how many elements are there in the first 5%? How many are there in the first 10%, 15%, 20%? Like I am making the frequencies. Okay. Still you need clarity, means what I will do is I will fully work out an example for you and show you in the next, so that you will have much more clarity. Okay. So this is one quantile plot for one item, right? Now the next quantile plot is, this is, let us suppose, for Banagudi junction stores. And for main road junction stores, you will have a similar plot. Now your QQ plot is nothing but, it is the comparison of prices at both the places. So you have to have equal quantile points and you have to plot them. Okay. That is the second point. Next. So scattered plot. So this is the second one. Next. So this is the one, quantile-quantile plot for unit price data from two different brands. Okay. Anyway, what I will do is I'll stop here, and in the next class I will show you with exactly the population, other stuff, because he has shown only some diagram, has not given population. So I will look for some worked out problem, totally I will work out, or I will create a problem and work out and explain you with more clarity. Okay. Thank you very much. Thank you. So have a happy new year to all of you. Wish you a very happy new year.